Ok, bună ziua, bine ați venit la webinarul nostru. Numele meu este Janusz Kovacs și sunt Business Development Manager pentru proiecte de robotică colaborativă în cadrul firmei Roboţi Company. Sper să mă auziți și să mă vedeți și să-mi vedeți și screen-ul, prezentarea. Dacă aveți întrebări în timpul prezentării, atunci vă rog frumos să scrieți pe chat. Văd că deja ați început să scrieți mesaje. Prima parte a prezentării va fi despre o scurtă prezentare despre firma noastră, chiar scurtă, iar apoi trecem la robotică colaborativă. Voi prezenta roboții colaborativi de la producătorul Franca din Germania și roboții de la Universal Robots. Mai departe o să mergem cu prezentarea domnului Dieter Charles din partea Pickit Belgia. El va prezenta în limba engleză soluții de ghidare a roboților prin camere Vision de la Pickit 3D. Ok. Deci, firma noastră, Roboţi Company, noi suntem o firmă înființată în 1997 și activăm în domeniul automatizărilor industriale. Oferim atât produse cât și accesorii în acest domeniu, iar de la diverse servicii până la furnizarea de celule robotice la cheie pentru o gamă foarte largă de aplicații sau operațiuni. La sfârșit vă voi informa mai în detaliu despre serviciile noastre. Ok, în momentul de față, pentru firmele producătoare, o mare problemă este creșterea cheltuielilor, salariile cresc, costurile de energie cresc, materialele prime au un preț crescut în fiecare zi și inflația. La noi, în Europa de Est, este o problemă și cu lipsa forței de muncă, pe care îl puteți experimenta aproape în fiecare zi, mai ales în cei care lucrați în domeniul de producție. O soluție pentru aceste probleme este automatizarea, adică automatizarea diferitelor procese de fabricație, robotizarea, adică implementarea soluțiilor cu roboți industriali, iar ceea ce vă voi prezenta astăzi este o soluție cu roboți colaborativi, adică integrarea roboților colaborativi pentru a sprijini procesele de fabricație. Care sunt aceste activități ce pot fi integrate, automatizate cu roboți colaborativi? Deci, teoretic și practic, aproape toate activitățile pot fi automatizate, dar aceste aplicații sunt cele mai des întâlnite, adică paletizarea, ambalarea, sudarea, operarea mașinilor CNC, procesele de dozare și alte aplicații pick and place, adică atunci când robotul preia ceva și îl plasează într-un alt loc. Acestea sunt de cele mai multe ori 80% din celule robotice fac activități repetitive. Deci roboții sunt echipați cu o serie de caracteristici datorită cărora sunt mult mai avantajoase decât roboții industriali. Ok. Ce înseamnă roboți colaborativi? Care este diferența între roboți colaborativi și roboți industriali? Roboții industriali se instalează dificil și instalarea lor durează chiar foarte mult. O celulă robotică cu roboți industriale se construiește în săptămâni. Iar acești roboți necesită abilități de programare, se montează, se construiește într-o poziție fixă, are o nevoie de spațiu mare și măsuri de securitate serioasă. Costurile de achiziție și de întreținere sunt ridicate. În tot acest timp, roboții colaborativi se pot instala foarte rapid și ușor. O să vedeți că un robot colaborativ poate ajunge la operare chiar după o oră, 2 ore de la scoaterea lui din cutie. Programarea roboților colaborativi este ușoară și sunt ușor de mutate. Asta înseamnă că se poate folosi aceeași robot pentru mai multe operațiuni. Se pot muta în cadrul producției. Poate fi folosit în spații mici, iar omul și robotul lucrează în aceeași spațiu, deci nu este necesar ca robotul să fie îngrădit. Rambursare rapidă și întreținere ieftină. Cum colaborează roboții? Adică ce este cuvântul colaborativ în expresia robot colaborativ? Aici puteți vedea 6 exemple de colaborare. Prima, deci o celulă robotică, deci robotul colaborativ poate fi folosit chiar și îngrădit, adică este un robot îngrădit, ca și roboții industriali. Iar în partea dreaptă, unde nivelul de colaborare este cea mai mare, vedem colaborare receptivă, adică robotul răspunde în timp real la mișcările muncitorului. Deci acesta este gama de colaborare a roboților colaborativi. Ok, începem cu primul robot, robotul Franca-Emica. Acesta este proiectat, dezvoltat și fabricat în Germania de firma Franca-Emica, care este un startup. Nu de mulți ani există pe piață, iar săptămâna trecută au venit deja cu al doilea produs denumit Franca Production 3, dar încă nu este lansat în media, deci nu pot să vă dau informații referitoare la acest nou produs. Robotul are 7 grade de libertate, 7 axe cu repetabilitate de 0,1 mm. De obicei, roboții au 6 grade de libertate, chiar și roboții colaborativi pe care le țin pe piață, dar de foarte multe ori al 7-lea grad este foarte important pentru diferite aplicații. Ceea ce este specific în cazul acestui robot este sensibilitatea. Deci, robotul Franca-Emica a fost dezvoltat ca să fie un robot sensibil, ultrasensibil, ceea ce se poate folosi în diferite aplicații unde este chiar nevoie de o sensibilitate foarte mare. Robotul are senzor de cuplu în toate cele 7 axe. Are o reacție rapidă la contacte, ceea ce este foarte important atunci când vorbim de siguranță. Deci robotul se oprește foarte repede în cazul contactului cu un operator. Programarea intuitivă. Robotul se programează printr-o interfață grafică bazată pe browser, iar prin metoda drag and drop este foarte ușor de conectat. Este accesibil, interconectat, are o precizie foarte mare și ceea ce v-am zis mai înainte, detectarea obiectelor. Deci detectarea obiectelor este cea mai importantă caracteristică a acestui robot. Are un simț tactil. Și controlul forței. Robotul are o dimensiune aproape identică cu mâna unui om și simțul are și simțul unui om. Programare bazată pe fluxul de lucru este o programare foarte ușoară. Aici puteți vedea un exemplu. Deci se configurează sarcina pe care doriți să o automatizați. Alegeți blocurile programate necesare. Deci aceste blocuri sunt deja incluse în interfața grafică. Aranjați aceste aplicații într-o secvență pentru a crea fluxul de lucru, iar pozițiile robotului se învață prin ghidare manuală, iar aceste poziții sau aceste mișcări sunt parametrizate prin aceste blocuri de program, app-uri. Ce se poate automatiza cu robotul Franca Emica? Așa cum vorbim și în cazul altor tipuri de roboți colaborativi, aproape orice. Dar aici ce vedeți dumneavoastră sunt aplicații care chiar de foarte multe ori necesită simțul tactil al robotului ultrasensibil Franca Emica. Înșurubare, testare PCB-uri, de exemplu, polișare, inserare, alimentare CNC, testare ecran sau alte aplicații de quality testing. Cablare, de exemplu, aici vedeți niște poze cu robotul Franca Emica fiind în producție, înșurubare și testare, alimentare CNC, inserare diverse obiecte, inserare cadran sau activități de asamblare. Robotul Franca Emica este un sistem modular, adică avem un robot, un braț robotic, alegem efectorul final, care în momentul de față poate fi un gripper normal, electric, servoelectric, sau un gripper pneumatic, sau dacă aveți dumneavoastră orice fel de echipamente, se pot conecta la robot, iar alegem pachetul software care este optim pentru aplicația specifică. Universal Robots ei se denumesc robotul colaborativ numărul 1 din lume. Universal Robots a fost și este companie care a inventat conceptul de robotică colaborativă. Este lider global pe piața roboților colaborativi. Aici vedem robotul Universal Robots 3E, care are un senzor care este un robot cu 6 grade de libertate. Seria roboților Universal Robots incorporează 4 tipuri de roboți, imediat o să le vedem. Acest robot are 6 grade de libertate și un senzor de forță cuplu incorporat, iar 17 funcții de siguranță și așa mai departe. Are un flux intuitiv de programare și programarea acestui robot este foarte ușoară. Deci, așa cum v-am zis, configurare, de la despachetare la instalare și programarea primei operațiuni de executat, doar o oră. Este foarte intuitiv. Este flexibil, un număr infinit de utilizări și operațiuni automatizate. Este foarte simplu de programat, iar aici trebuie să amintesc și programul Universal Robots Academy, care este o platformă online unde oricine poate învăța cum se programează acești roboți. Chiar și în 87 de minute oricine poate deveni programator de roboți. Universal Robots este o soluție foarte sigură. Acești roboți sunt instalați deja în peste 50 de țări din lume. Chiar recuperarea investiției este chiar foarte scurtă. Aici vorbim de o productivitate a robotului de 24 de ore, 365 de zile pe an. Este o soluție flexibilă. Aici putem vedea câteva aplicații, adică inspecția calității, operațiuni de înșurubare, turnare prin injecție, lipire, dozare sau sudură, ambalare, paletizare, analize de laborator, operarea mașinilor unite, de exemplu CNC-uri, sau asamblare industrială. Aici vedem cele 4 tipuri de roboți, Universal Robots, și vedem că raza lor de acțiune este între 500 de mm și 1300 de mm, iar sarcina utilă de la 3 kg până la 16 kg. Dacă vorbim de spațiul necesar al robotului, vedem că amprenta lor este chiar foarte mică și în cazul acestor soluții colaborative nu necesită o îngrădire. Deci acesta este spațiul care teoretic este necesar pentru montarea robotului. Ok, în cazul în care doriți să aveți un proiect de automatizare prin roboți colaborativi, noi vă putem ajuta. Putem să vă furnizăm acești roboți, adică roboții Franca Emica Universal Robots pe care l-am prezentat astăzi și roboții AUO. Putem furniza servicii de consultanță pentru aceste proiecte, evaluarea riscurilor, iar putem integra acești coboți în linii de producție existente. Putem chiar dezvolta soluții specifice, particulare pentru dumneavoastră, soluții atât hardware cât și software. Vorbesc acum de soluții personalizate, iar avem o mentenanță și service 24/7. În cazul în care aveți proiecte deschise sau doriți informații suplimentare, dacă doriți un meeting să vorbim despre proiectele dumneavoastră, aici aveți datele mele de contact. Dacă intrați pe pagina www.covaci3.com, atunci găsiți acolo un link, Book Now. Acolo vă puteți programa un meeting online direct. Ok, acum trecem la partea a doua a webinarului și vom vorbi despre ghidarea roboților prin camere Vision 3D. Ok, Dieter, now is your part. Let's speak a little about robot vision. You have to unmute yourself.
Yes, thank you, Janos. Thank you so much for the introduction. Is it possible to give me the rights to share my screen, please?
Of course. Now.
Excellent. Let's share. Do you see my screen?
Yes, great.
Excellent, perfect. All right, so good afternoon, everybody. Thank you so much, Janos, for this first presentation about collaborative robots. My name is Dieter Scherler. I'm based in Belgium, about 50 kilometers away from Brussels. I'm responsible for sales in Europe, with exclusion of the German-speaking areas. So that's a large area to cover. And I work very closely together with Kovacs Trade Company for the regions that Janos just specified. So Bulgaria, Romania, Hungary, and also Moldova. And in the upcoming 20 to 30 minutes, I'm going to explain you a little bit more about our solution and our company, where 3D vision could be applicable and a big help for collaborative robots and also for industrial robot automation. Just to kick off, I like to start with a nice quote of one of my inspirators, and that's Albert Einstein. Most of you probably know him. And one quote that is claimed to be one of the quotes of Albert Einstein's, although there's no real records of that. But one of the inspiring quotes is, "Make everything as simple as possible, but not simpler." And it's an interesting quote, I think personally, because okay, yeah, there's some ambiguity, and what does he actually, what does it mean actually? Well, if you make a solution, it is always important to keep in mind to keep it simple from the start. The thing is, if you have a solution and you make it afterwards simpler, you have the risk to lose certain important important features of the solution. Yeah. And also with that in mind, Pickett has always put it as a priority one to make 3D vision as simple as possible, yeah, so that it is helping robot programmers, but also starters or beginners who starts to work with robots, and also for utilizers who are dedicated and utilizers of collaborative robots. And with this in mind, I like to first of all introduce you to our company. So Pickett is based, the headquarters are based in Belgium, in Leuven. That's near to Brussels. But due to our solutions, it was really important to expand quite immediately international, because the field of the field of applications and also the amount of applications, you need to seek that globally. So the first thing what we did was developing Korea, because Korea is familiar and quite renowned for the large population of robot applications there. And from there on, we also developed a sales hub in the DACH region in Germany, and now also in the US. So we have a local office also in the US. And further on, to support our customers in their local language, we have built a consistent and coherent distribution network across the globe, where from Kovacs KFT is, for instance, one of the distributors and integrating partners. And across the globe, we have already multiple end customers. First of all, because of the maturity of the industry and the utilization of robotic solutions and robotic automation, of course, we have a big presence in the automotive industry and the supply for automotive solutions. But we also have solutions running in metal machining for feeding, for instance, of CNC machines, also in the food and beverage, but also in electronics and so on and so on. So the application portfolio is quite versatile. Yeah. Just to give you a bit of a background about our history, so we are considering ourselves not longer as a startup. So we have a mature product and a solution put in the market with success, but we are more a scale up. So what we are currently doing is utilizing and commercializing the existing platform, and of course further developing the platform. So the origin of our company is a software company. That's our mother company is Intermodalics, and specialized in vision in combination with software. And their first task actually, and that's the origin of the Pickett solution, is when we had a task and an assignment for the European Space Agency. And then in 2016, we founded the company Pickett, dedicated for 3D vision guidance for robotic automation. And now, plus 5 years later, 2022, we have already more than 500 running applications. And those do not include demo systems and also academic and research systems that we have in the fields. And we are present in more than 40 countries across the globe. One of the applications that we recently, for instance, commercialized was the billet gripper, which is a dedicated gripper for forging industry to grip billets and to put them in various applications. And that's what you can see in the animation on the right side. There's, for those who are familiar with 3D vision, there's multiple ways of 3D vision detection. Yeah. The technology that Pickett is utilizing is 3D vision, where we do a scan by a reflecting of light and having the detection and creating a point cloud by infrared detection, or also by light detection. Yeah. And it combines this 3D shape or the 3D point cloud with a 2D picture, so a color image. And by utilizing this scanning technology, we have very nice results in detecting overlapping parts, but also slight variances in size, varying materials, and also being capable of detecting glossy and matte colors from the parts. So that enhances and enables us actually also to cope with variability in terms of lighting, outdoor lighting or changing lighting conditions in the process. And that's one of the first question marks that we always get when we talk about sensor technology for 3D point cloud detection. A lot of customers who are already familiarized with 2D detection sometimes have the fear of changing lighting conditions, and okay, that definitely impacts. But for 3D vision and the technology that Pickett is utilizing, it is less critical and less how you say that, sensitive to changing lighting conditions. In combination with the 3D vision, why do we offer this 3D vision as a solution in the market? And if you just look towards the demands of the industry today, is that it is really important to come with a production faster to the market. And if you want to go fast to the market and you want to automate certain things, then 3D vision in robot guidance is definitely a tool which can help you. Also, higher manufacturing efficiency. So yeah, you need to make sure that you have a very robust and reliable and safe solution, so that if you once are in production, that you do not have unpredicted outages or stops and so on. And the key differentiator comparing with no vision, so let's say purely strict programming, is that 3D vision enables customers and end users with the required flexibility. Yeah. So that means actually, okay, if you have over your production cycles a slight change in the parts, or you need to utilize the same robot cell for another application or another part, yeah, 3D vision enables you to do so, so that you do not have to do the whole study and the whole reprogramming. And actually, in terms of words, where 3D vision can help you making the scan of the parts or teaching the parts very quickly and without any coding involved. And that helps you to also take advantage when there is a demand in bigger product variability. Yeah? So variances in terms of throughput, but also variances in terms of multiple types of parts that need to be handled or assembled or picked. Yeah? So that's also a third solution what we offer. If you look towards a complete portfolio of Pickett, so we have multiple automation scenarios, which you can see on the on the left top part. So we are, of course, because of our brand name, we are definitely more renowned for bin picking applications and billet picking applications, but also the platform can be utilized for depalletizing or even surface treatment and sanding, or even putting and placing parts like screws in dedicated spots like holes, which are then detected by the 3D vision system. And more are to come. So we are also open for making developments and enhancements on the current platform. So what is the platform that we are utilizing? Well, we have 3D vision core components and a robot integration network. So what does that mean? Well, we have variable interfaces, which I will show you later, which can interface with the multiple brands which are available on the market. Yeah? Then we have in the software, we have multiple 3D vision application frameworks. Where you can select the application that you want to utilize and then configure the application that you want. And then on the hardware side, we have multiple components. So we have a whole camera range in our portfolio from a standard range to an HD range, which I will show in the later slides. We have the processor, which we provide with the required GPU, and everything is tested, so it should work as a plug and play solution. And we also have, for instance, the billet picking applications, end of arm tools. So we have developed a dedicated arm to enable and enhance the billet picking applications, and also to provide the required robustness. And then we also have multiple accessories in our portfolio. Yeah. And this is actually on the technology side, what we have in our portfolio and where we help our customers with. Of course, what is also important is the implementation. Even though this platform is quite intuitive, it is really important during, like Jan already highlighted, to provide the required consultancy and support and knowledge transfer to end users. And we help by providing equipment by our partners for demos, but also for setting up a proof of concept for certain more tough applications. And then further on, when the proof of concept has been successful, we can help together with our partners to provide the required implementation and commissioning service for the 3D vision system, in combination sometimes with a robot integrator if it comes up to industrial robots. For collaborative robots, this is also a way to look at it, but the implementation service and commissioning services, of course, will be on a different level and less complicated. Yeah? And then, okay, once the system has been installed, you have all kinds of lifecycle support services which might be required, even though the system is very robust and is kept up to date. But sometimes, it is necessary to have some support or to reach out, and we do have local support and global support to help our end customers with their 3D vision system. Yeah. So how does the technology look like? As I already highlighted a little bit in the previous slide, just in a framework. So in practice, it comes with a 3D vision camera, the processor, and then you can actually, through HTML connection, through an UTP connection, you can log into the processor, do your required configuration, and then you have the various applications that you might pick. And then there is also a connectivity to your robot, where the processor is actually explaining what are the XYZ axis to pick apart. Yeah. As I already highlighted, so the system which we have developed is working with an open interface for making the connection to the robots. And here you have, for instance, an overview of big variants of multiple robot brands that we have that we are working with. Yeah. And then we have also the different applications where this system can be utilized for. Yeah. So in terms of cameras, so we have two types of cameras mainly in mind. We have the Picket L camera, which is the standard camera, and it can cope with parts from 50 by 50 by 10 millimeters. Although I need to highlight here, this is really in the fixed position. Yeah. In some cases, for instance, for billet gripping, and I will show you some use case for that, we can go closer to the parts when the camera is mounted on the robot arm, yeah, on the end of on the robot arm, and then we can go closer and have a more exact detection. So this size, please do not point yourself. This is for the fixed position. So we can go also to smaller parts. Of course, if you talk about plate picking, for instance, to feed, for instance, a welding machine or a bending machine or a press, okay, plates, they can have a large surface, but they are most of the time very slim. And in that case, for this slimmer size of parts, we opt to go for an HD camera. Yeah, the difference between an M and an L HD camera, and also here, is the field of view. Yeah. So for instance, if you have this camera built on a fixed position and you want to scan a complete entire Euro pallet, then we would recommend to go for the L camera. Yeah. If you are able to scan a smaller field of view, or you could even mount this camera on the robot arm, then yeah, you can cover actually multiple scanning locations when it is on multiple when it is mounted on the robot arm. So by this, then the M solution can work as well. Both the cameras are industrial grade, yeah, and EMC tested, and they are quite robust, of course. Yeah, it's also, especially if the camera is mounted on the robot arm, yeah, it's recommendable to put a protection around it, of course. The core competence of Picket is really on the software. Yeah. So we have developed a very intuitive software platform, which is very visual and which is easy to configure. Yeah. So for the setup of a system, I will not go into those details. We can highlight those maybe if you have further interest in a next meeting. But the first, it's actually the configuration happens in 3 steps. Yeah. First, you define where to pick. So you define your region of interest, where to scan. Second step is what to pick. So there you can there you create actually your product file, and you can make multiple product files. So depending on the variability of your parts, and then the third step is actually how to pick. And in the how to pick, you define actually your your picking strategy. So where does the gripper need to go, and which location does it need to pick the part, and okay, does it need to pick the first part, the highest part, or can it see the most pickable part? This kind of settings you can configure. Yeah. And well, at the base of this slide, you can see, okay, that we have multiple very happy customers, which are really happy by utilizing this platform, and we continue developing this platform to enhance the user experience of our customers. As I already highlighted, also on the lifecycle services and on the support part, and so we have a very well documented knowledge base, which is free accessible. So feel free to if you have further interest, to go to our website, and there you can find a complete knowledge base, which is explaining the different interfaces, how to set up the system, and so on. So actually, you could help yourself with getting familiarized with the system. There's also possibility to, in the software, when the system is connected to the internet, to take even a snapshot and send that snapshot to the Picket support and the local support to ask for advice or help, or ask for remote help. Yeah. And we also have a global support team available, which can call in and help you remotely. Yeah. So that's really the advantage of working with a digital infrastructure, is that that we can do these days with or without COVID circumstances, that we always can help our customers with their system. And then I like to give you two nice examples of satisfied customers for two different variants of applications. Both applications are with industrial robots, but we definitely do also have nice references with collaborative robots. So the first case is with Colin Milas. Maybe it's not really clear on the picture, but here you can see actually the robot arm with the 3D vision scanning system on the robot arm mounted. Yeah. And this is an application for a furnace, to feed a furnace billets into a furnace. Yeah. The picking cycle time that we achieved is plus or minus 15 seconds per cycle. And okay, to guarantee a good functioning of the furnace, it was required to feed billets within 30 seconds into the furnace. So we definitely achieved that. And even if there is a mistake by picking, or a part was not picked correctly, we can still manage to stay in between those 30 seconds. Yeah. And due to the advantages of robots and robotics and vision, and as well the dedicated approach that Pickett helped the customer with, they were really happy, because they have actually, we built a complete integrated solution for them, and not only the robot, not only the software, but the robot, the camera, the gripper, and so on, and bring this live on site with the customer. The second application was, for instance, for back depalletization with Van Tuyl. Before, they were doing this depalletizing by manual workers, and about 1,000 bags had to be offloaded off a pallet every day, for multiple pallets every day. And the challenge was also that they had multiple variants of bags, and that was a bit the challenge they had, to say, okay, how can we automate this? And then we came up with the solution. Okay, you can change over very quickly with your picket system from one bag type to another, or from one pallet type to another, to enable yourself to automate this. And this is actually okay. It improves the throughput of and the feedstock towards the production process, but also in terms of ergonomics. So if you need to do this manually, this is not really a very interesting job to do, and also you have the consequence of back problems of your workers as well. So actually, this solution really helped the customer not only to optimize his production, but also to optimize his satisfaction of his workers. And with this, I like to conclude with this presentation. So you can always reach out to Janos and to Kovacs Trade Company to find out more about our solution. But feel free to also find more information on our website, picket3d.com. We also have online documentation, which you can find there. And our general sales email address is sales@picket3d.com. Of course, for the region of where Kovacs KFT is occupied and responsible for, we will always bring them also in the loop. And yeah, with this, I hope to show and prove you that that we truly enable flexibility in robots automation. Thank you.
Thank you, Dieter. Thank you very much for this interesting presentation. Dacă aveți întrebări, vă rog să scrieți în chat. Aștept câteva secunde să văd dacă sunt întrebări. Dacă nu, atunci vă doresc o zi plăcută. Vă mulțumesc că ați participat la acest webinar. Și în chat aveți un link prin care puteți programa un meeting. Dacă aveți proiecte deschise sau doriți informații suplimentare, vă stăm la dispoziție. Vă mulțumesc mult. O zi plăcută vă doresc. Toate cele bune. Thank you, Dieter. I will close now. Thank you very much and have a nice day.
You too. Thank you, everybody.
Okay.
Bye-bye.
Bye-bye.